Hello. Welcome back to my series on the 2024 AP Calculus BC free response questions. Today we'll be going over number 5. Alright, so number 5 gives us this table of f prime of x at selected values of x. F is twice differentiable, and f of 0 equals 0. So A, h of x is defined by definite integral from 0 to x of square root of 1 plus f prime of t squared dt. Find the value of h prime of pi. Show the work that leads to your answer. Okay, well, h prime of x is equal to the square root of 1 plus f prime of x squared by the fundamental theorem of calculus. So, h prime of pi, square root of 1 plus f prime of pi, all squared, and that equals 1 plus f prime of pi in the table is 36. So square root of 1 plus 36 equals square root of 37. Question B. What information does the integral from 0 to pi of square root of 1 plus f prime of x squared provide about the graph of x? So the arc length formula for a function f of x on the interval x between a and b is the definite integral from a to b square root of 1 plus f prime of x squared dx. So this formula is simply the arc length from 0 to pi of f of x. Arc length of f of x from x equals 0 to x equals pi. So for question C, we need to use Euler's method starting at x equals 0 with 2 steps of equal size to approximate f of 2 pi. So we're starting at x equals 0, and we're going to x equals 2 pi, and we need to use 2 steps of equal size. So that would be 2 pi minus 0 over 2. That would equal our delta x, those steps, and that would equal pi. So for Euler's method, we're basically going to set up a table like this. All right. F of 0 is 0. So f prime of 0 is 5. Remember that delta x is pi, so f prime of x times delta x is 5 pi. And f of x plus this is 5 pi. So we increment the x by delta x. Now our estimated value for that is 5 pi. F prime of pi in the table is 6. 6 times pi is equal to f prime of x delta x. And then our new f of x is 5 pi plus 6 pi equals 11 pi. And then our approximation for f of 2 pi is 11 pi. And now for question D, it's asking find the antiderivative of t plus 5 cosine t over 4 dt. And then it asks show the work that leads to your answer. So Usually when you see a function times another in an integral, it might be useful to use integration by parts. So remember that the formula for integration by parts is that if we have an integral u dv, that is equal to uv minus the integral of v du. And we're going to use that formula and apply that here. So I know how to anti-differentiate just integrals with cosine. So it'd be much easier if I could get rid of that t, or maybe even that t plus 5. And I can do that by setting that equal to u. So if I set u equals to t plus 5, then du equals dt. That would make dv, whatever else is left, cosine t over 4 dt, and anti-differentiating that, you get 4 sine t over 4. Now, I'm going to have an antiderivative in a form that's very easy to anti-differentiate. Instead of having some multiple of t, this is going to equal t plus 5 times 4 sine t over 4 minus antiderivative of 4 sine t over 4 dt. And that's going to equal negative 16 cosine t over 4, and all of that plus c. Now, if you're a bit confused about how I went from here straight to here, I did the chain rule, but accounting for it in the reverse direction because we're integrating. So I know that negative cosine becomes sine, and if I have like t over 4, and I'm differentiating this, I'll get back to this, because if I multiply by 4, that accounts for that t divided by 4. That's just what was going through my head. And anyways, we can just simplify this and make this plus, and that's our answer. And don't forget the plus c. Thanks so much for watching. If you found this video helpful, I'd appreciate it if you could like or subscribe, and I'll see you in the next video.